Hello everybody, have a nice day today. We will continue structure function. Today's topic is system safety quantification, minimal cut and path representation using structure function. The content of today's presentation, we will start with minimal path set and then see the structure function using minimal path sets. Then a couple of examples we will discuss. Then we will go to minimal cut sets, where the same fault tree will be converted in such a manner that you will get the minimal path sets, and then with set of we will see the structure function using minimal path sets, and then same examples, number of examples will be discussed. And we have taken material from this book, Probabilistic Risk Assessment and Management for Engineer and Scientist, written by Kumamoto and Henle. Hope you will enjoy it, and I understood also that in the last class when we have discussed the structure function, the fundamental mathematics behind it also been understood by you. So, this is in continuation with the previous lecture. So, all of you know cut set. So, you go back to that lecture where we have developed the cut sets for a fault tree using Mokas algorithm, and you will see that the cut set particularly is a set when, and if it is a minimal cut set, then all the events of that cut set if occurs, then the top failure event will occur. So, as a result, this is one cut set, and with this cut set with an AND gate linked with the top event using OR gate also. So, the AND, because all those basic events should occur for the top event to occur. So, this is cut set 1. Similarly, second one cut set 2, cut set 3. So, like when you have the cut sets, minimal cut sets with you for a particular top event, then you can represent that in this form of fault tree. So, that means why it is OR gate, any one of the cut set if occur lead to the top event to occur. Why AND gate? All the event in the cut set must occur for the top event to occur. Now, this explanation you have already seen. So, now what we will just formally go for the structure function of this particular fault tree. Then we will define the basic events in the cut sets. So, one is that how many cut sets we have. This is cut set 1, cut set 2, and this is cut set M. So, we will basically use that j equal to 1 to M to represent the number of cut sets, and then against under each cut set there will be n number of events. So, for the first cut set there is n1 events, second cut set there will be n2 basic events, like jth cut set there will be nj basic events. So, if I represent this as j, so this is nj basic events. So, that will be represented by I. So, I equal to 1 to ni. Okay. So, 1 to nj. If it is a jth cut set, 1 to nj. Okay. This is the notation. Using this notation, we are defining these cut sets. What is the first cut set? B11, B21 to Bn1, j equal to 1, j equal to 1. So, Bn1 into 1, this is the first cut set. Similarly, jth cut set, similarly, mth cut set. Now, if we want to define indicator variable for each of the event, then we also require to use I and j. So, Yij is the indicator variable for event Bij. I stands for the event, basic event, J stands for the particular card state. So, that is what is written here, that J refers to a particular card set, I refers to an event in the card set, and M and N, that variable M and N denote the number of card set and number of component in the card set respectively. So, if you write M is number of card set, then Nj, if I write here, that the number of event, basic number of component in the jth card set. So, that sense you can write. Okay, so, let me repeat. First we have a fault tree. From the fault tree you developed the found out all the basic card sets, minimal card sets. So, from original fault tree to this minimal card set fault tree, that equivalent representation of original fault tree is this, where as we know that a card set means a set if all the element of that set occurs, then top event occurs. So, if there are m card sets, that means the m ways, the at least independent ways, that m any one of the card sets leads to the top event to occur at least. So, what will happen, that there will be 1 or 2 card sets, 3 card sets, there can be means many number of card sets, many number of combinations. So, that is why here OR gate is used and here AND gate is used, that is for any fault tree when it is represented by card sets, then the equivalent fault tree using card set is this. And then they are that for their notation for the basic events and or the card set and the indicator variable will be like this. Okay. So, what happened now, that means we have the fault tree with minimal card sets and we have defined the notations. So, now what we want to see, that what will be the structure function for it. So, let us see the structure function for this fault tree, So, structure function for the top event that we are writing psi y, and it is an OR gate. So, we will be using this symbol. So, how many inputs are there? There are m inputs. So, j equal to 1 to m inputs. Now, again each of the AND gates, there are n j number of inputs. So, because of AND gates and there are so many AND gates. So, what we will do, basically we will put the bracket and then we will write that intersection I equal to 1 to n j, indicator variable is y I j. Let me repeat, because of OR gate you have to use union symbol. Okay. So, j equal to 1 to m, union symbol. Because of AND gate you are using intersection symbol. AND gate inputs are b 1 j to b n j j. So, that is why I equal to 1 to n j y I j, and OR gate union symbol, how many inputs? M inputs, that is why j equal to 1 to m. That is what is your structure function here. So, that is what is written here. So, psi y equal to j equal to 1 to m union, then intersection I equal to 1 to n j y I j, or this can be represented like this, where this union is there. This is nothing but the multiplication I equal to 1 to n j this. So, psi is this. Now, when there is union, so you know that this is basically the union case, and when we put down the algebraic form, you have to write like this, 1 minus I equal to 1 to n this. So, that is what is written here. So, psi y equal to 1 minus j equal to 1 to m, 1 minus j equal to 1 to m, and this quantity will be 1 minus j I equal to 1 to n j y I j. Okay. So, let me repeat, so that you will not get confused. First one, we were defining psi y. What is psi y? Structure function for the top event. There are two gates, OR gate, which will be denoted by union. Then there are another gate combination. So, the several AND gates. Okay. So, now how many AND gates are there? That is j equal to 1 to m. How many inputs to a particular AND gate? That is I equal to 1 to n j. What is the indicator variable? Y I j. So, this is my structure function. When you go for writing it in algebraic form, this one, that the intersection part, you say that intersection part is this is basically multiplication one. So, the intersection part, this part is converted to this multiplication. When you write union, you will be writing in this form. So, but then this union part you are writing in this form, that you have seen earlier in last class. Okay. Now, what we do, in order to get rid of this clumsy equation, we will put a structure function which is k j y, then for AND gate, for this gate. So, for this gate, you know that is AND gate means it will be the intersection. So, that means k j y is denoted by like this. How many inputs? N j inputs. So, I equal to 1 to n j, y I j. So, this is basically structure function for the AND gate. So, then for this what will happen? Here this equation will be changed to this 1 minus j equal to 1 to n, then intersection j equal to 1 to m 1 minus k j y. Okay. So, this is what is your structure function representation for the minimal Cartesian representation of a fault tree. So, what happened? This is the final form, and this one is the structure function for AND gate. So, once you know this, now given a fault tree, you can very easily find out the final structure function. So, that is what we will see now. Let us concentrate on this example. So, this example, this is the fault tree. A, B, C basic events, 3 basic events, it is an AND gate, this is OR gate, this is the starting point. We have converted this to equivalent fault tree using card set of this fault tree. What are the card set? Card set will be, there will be two card sets, A must occur, B or C occurrence will lead to, so A B and A C. So, there are two minimal card sets, A B and A C. So, this one is represented by like this. So, when we know the card sets, so first you must know how many card sets, here 2 card sets. So, 2 AND gates will be there, and input to the every AND gate will be the element of the card set. First one is A and B. So, A and B, second one A and C, A and C. Then these AND gates will be linked with the top event by an OR gate. So, OR gate. Okay. Now, what we will do? We have earlier seen that for minimal card representation, what is the structure function? The minimal card representation, the structure function is this. So, first find out the structure function for this. So, this one will be k1 y. k1 y is here A and B. Okay. So, that means this is y1, this is y2, again this is y1 and this is y2 if we say. So, ABC y1 y2 y3, A is y1 y2 y1 y3. Okay. So, now this is AND gate. So, it will be y1 y2, k1y is y1 y2. Now, k2y is y1 y3. So, you have k1y and k2y. Now, the structure function representation with OR gate will be this. Now, put 1 minus this one j equal to 1, 1 minus k1y and j equal to 2, 1 minus k2y. k1y is y1 y2 and k2y is y1 y3. So, this is your structure function. Now, what happened? If you do little more exercise manipulation, then you will be getting this expression. So, y1 y2 plus y1 y3 minus y1 y2 y3. So, instead of using this structure this minimal representation, if you simply start with this and use the structure function, you will also come to this equation. Okay. So, but when you make minimal cut representation, things become easier because of this simple structure and OR and AND gate only. First find out the AND gate structure functions, then use the OR formula algebraic form and get the final structure function. And now, if you want to find out the QST at time t equal to 2, this will be expected value of psi y, then expected value of everything, expected value of y1 y2 plus expected value of y1 y3 minus expected value of y1 y2 y3. As y1 y2 y3 are independent, so this will be multiplication of the expected value, this will be multiplication of its expected value of y1, expected value of y3, similarly this. Okay. So, I hope that now it is clear. I hope so, it should be clear. Let us see another example. Here you see what is happening. This is my original fault tree. So, we have found out all the cut sets. How many cut sets are there? 4 minimal cut sets. Now, these 4 minimal cut sets, this is 1, 2, 3 and 4. First one has no gate, it is straightway 1. So, directly with this OR gate. Here you will be getting k, suppose okay, if you write k1y equal to, this is basically A, k2y this will be BC, k3y this will be BDE, like this. So, k1y YA, k2y YB YC, YB and YC, k3y YD, YB, YD and YE. We are using the indicator variable. So, that is why I will not write B and C, we will write multiplication of the indicator variable. So, this one YB, YD and YF. So, now structure function, this is OR gate, you know this formula. So, 1 minus k1, 1 minus k2, 1 minus k3 and 1 minus k4, because 4 cut sets are there. What happened? You just decompose it further to its lowest form, you will be getting the another the final form, and then use the expected value and get the QST and finally the availability, all those things. Let us see another one. So, here is another example. This is the pressure tank rupture case. So, how many cut sets we have? We have so many cut sets, 7 minimal cut sets. So, 7 AND gates, including this 1, 2, 3, 4, 5, 6, here also one item AND gate. Okay. So, that means 7 structure functions for AND gate K1 to K7, and all those 7 structure function linked with OR gate, use the formula, this formula, and then finally you get this, and then again go to the lowest level, if required. Just you check that if in the product term there is repeat events, then you have to go to the lowest level. If suppose this one B1, here B2, B4, here B2, B5, yes, repeat events are there. Here B2, B6, B3, B4. So, that means you go to the lowest level representation and then take the expected value. Otherwise, you have to use some more formula like partial pivotal decomposition, exclusion, inclusion formula. Here you see that voting gate case, this voting gate equivalent card set representation is this. This structure function you have already seen. Now, here what happened, you see that okay, here let me add here just some just some mistake in the sense of indicator variable. So, for indicator variable this will be we are writing like this, that this is YB1, YB2, YB2, YB3, YB3, YB1. So, in that way you will use in terms of Y. Okay. So, fine. So, this is not a problem and you can do it very easily, you can do it. So, now let us see that second one, that here we are using Y1, Y2, Y3 or YB1, YB2, YB3. So, if you use YB1, YB2, this will again become clumsy. So, that is why straight away we use Y1, Y2, Y3. And this particular example I have shown you in the last class also, then I have shown that the QST is changing. Basically QST, if you use expected value earlier and then the QST value, and when you go for the lowest level decomposition, the QST value is different, and that is what the dependent product terms. So, wherever there are dependent product terms, so what you will do, you will basically better to reduce up to the lowest level. Otherwise, you have to use that partial pivotal decomposition method or inclusion exclusion approach method in between to get rid of exploring or digging it into or up to the lowest level of resolution. Okay. So, I hope that you have understood it. Okay. This is what is our card set representation. Now, what I will do, I will just go to the second part of today's presentation, that the minimal path representation. You have seen that the card set talks about the failure and path set talks about the success. So, but we are interested in the failure part. So, what will happen if you find out the path sets and you want to find out the top event failure, then the simple rule is here that in the card set representation, AND gate will be converted to OR gate in the path set representation, and card set representation OR gate will be converted into AND gate in the path set representation, keeping the basic events as failure event and top event as failure event. So, as a result, if you go back and see the minimal path representation in terms of minimal card sets, so you have seen that here we have used this OR gate, and here everywhere we have used AND gate. This is for card representation. So, but these are all failure events, and this is also failure events. In path representation, what happened? We keep this failure event and top failure event intact. So, in order to go for path representation, this AND OR gate is converted into AND gate and AND gate is converted into OR gate. So, that is basically path representation. Now, what will happen or when the top event will occur? You see, this is OR gate, means any one basic event of the minimum path set. Here also any one of these path sets, all those things at least one in each of the path set if occur, then top event will occur, because this OR will be satisfied and finally AND will also be satisfied. So, that is why what happened in the path representation, we are basically saying that any one basic event in the path set, at least one event leads to the top event to occur, but those events for the path sets what you have found out earlier. So, okay. So, with this structure function we have to develop, but structure function looks into the gate. What gate? This is my AND gate. So, my structure function, the first part is intersection. This is OR gate. So, in the second part it is union. So, union I equal to 1 to n j, y I j is the indicator variable, and this is AND gate. Intersection, how many path sets? M path sets, j equal to 1 to m. So, this is my structure function. So, this one can be written like this. Now, algebraic form of this is 1 minus this, and finally, for this one if we decompose further, so algebraic form will be this. So, this is a final algebraic form. Now, then what will happen here? Now, we will just find out that structure function here, this is for rho 1 y, this is rho j y, and this is rho m y. That means, structure function for OR gate you find out and then put into this equation. So, structure function for OR gate, for the jth OR gate, we can write like this, rho j y equal to this, because it is OR gate 1 minus that multiplication of all those into 1 minus y I j. This is written here. So, now this one minus this means this. So, if I put rho j y here, this function will be like this. Okay. So, that means, if you go for minimal path representation, what you have to do? You have to first find out the structure function for all the OR gates, which is basically input to the top event using logic AND gate, and then find out the structure function everywhere and get its algebraic form, and then AND gate, this is the multiplication form. So, that way it will be written like this. Okay. So, using this analogy or using this representation, we will see all those examples what we have seen for the card set representation. So, let us see first one. This is my fault tree, this is path representation. So, how many path set? 2 path sets, and so here rho 1 y will be nothing but y a, and rho 2 y will be nothing but this. Okay. So, rho 1 y a, rho 2 y a is found, and you put into this equation, you get this final. This is my representation for structure function. The second example, this is leakage of gas, this is original fault tree. Here this is the minimal path set representation, 4 path sets are there, AB, ACD, ACB and ACE F, and then we have generated 4 card set structure function. You found out every one, and then finally you have AND. So, you multiplied all those card set structure function, and if you decompose it, you will be this is the function, and further you can multiply and get the values. Okay. Once you have the psi y, you know how to calculate the unavailability, the same formula you will be using. You see, this is another one, pressure tank rupture, this is original fault tree, this is our path representation. How many? Only 2 paths, but in card set you have seen there are so many card sets. Here path set 2 paths. So, 2 structure functions for the 2 OR gates. Then final structure function which is multiplication, and you are getting this equation. So, I am repeating this for these things because you will have more example and you will be able to practice, and then you find out that what way it should be done. It is not a tough task. Don't get exhausted by this different that equations like the symbols. Don't get over exerted by this. Think for the concept first, then put the equations. So, for your benefit, first is the fault tree, then the path representation. Once you have the path sets, if there are m path sets, there will be m or m structure functions for m OR gates, and then final structure function for the top event, and that final structure function will be the multiplication of the all of the OR gate structure functions. Okay. And then rest of the things are algebraic only. You have to just manipulate algebraically, and final form you will get. You can use expected value in between if you find that there is no terms are not repeating in the product terms, or the basic events are not repeating in the product terms. So, otherwise it is always better to find out the lowest level of equations. Okay. By lowest level, we are saying that when that decomposition stop here, you cannot further decompose these things. All those arithmetic operations, algebraic operations are finished. Okay. So, then another one. So, this one you have seen that this voting gate one, its path sets you found out 3 path sets. In fact, because of the 2 by 3 path and cut sets having almost that similar structure, and you are finally getting this expression. Okay. So, this is what is our lecture today, and we have taken the concept from this book, and please let me I can say summarize. So, what is this? We have started with system safety quantification, that is very important. Now, in system safety quantification we consider fault tree first, and we have considered that there is one top event. By unavailability, we say that probability of top event, that is the unavailability QST. Then once you have unavailability, you can find out availability and other things. Our sole purpose in the system safety quantification basically how to find out the unavailability. That means how to find out the probability of top event. Probability of top event given a fault tree, there are many methods like gate by gate method, cut set method, all these things are there. In this particular last few lectures under system safety quantification, we have started with quantification that RBD, reliability block diagram. Then we have shown you that truth table. Then we have shown you the structure function, that is the fundamental structure one, the basic one. Basic one means from the fault tree only. Then we have shown you the minimal cut set and structure function. Finally, minimal path set and structure function. The sole purpose is basically make the system safety quantification issue simpler. So, there will be a certain case where RBD will be better. When you have a series system, RBD is better. When you have a parallel system, RBD is better. But if there are system like parallel series and parallel combination, maybe RBD is not that easy. So, there may be some structure like bridge structure when you will find out RBD is difficult. So, there you may find out the truth table is useful. Now, truth table basically is an enumerated one, it will basically give you all possible combinations. So, that is why it is a it is probably the more accurate one, or otherwise I can say this is your knowledge about this total system in terms of the top event occurrence will be much more clear, nitty-gritty is known. Then what happened, then we have gone for the structure function. In structure function, instead of using the basic event probability, we have used the indicator variable for all the basic events, because the basic events have two states, either it is event exists or event does not exist. So, that means then indicator variable y I equal to 1 or 0 depending on event exists or does not exist. Then with the fault tree and an OR gate structure, what happened, the structure function for the top event is possible, where the indicator variable y psi y equal to 1 or 0 depending on top event exists or does not exist. Now, when the fault tree will be very big, then it will be very difficult for you to find out the structure function using the from the basic fault tree. It is better to convert the fault tree to that equivalent that minimal cut fault tree or minimal path fault tree, and then what will happen, there you will be having only two sets basically two gates, OR and AND gate. So, in case of minimal cut set, you will be finding out the all AND gate structure function first, and then the OR gate, using OR gate the top event structure function will be created. And for the minimal path set, what you will do, you will first find out the OR gate structure function, and then final another one AND gate structure function, where inputs will be the all the path sets. So, when there is AND gate, it is basically simply multiplication. When there is OR gate, then it will be 1 minus that multiplication of 1 minus all indicator variables. Suppose and if that means there will be product terms in the structure function representation, 1 minus some product term, and in the product term, if you find out there are dependent basic event, means the event appearing in more than once in different product terms. Under such situation, it is recommended that you basically explore or find out the lowest level equation, and then use the expected value of indicator variables to find out the top event occurrence or unavailability of the system. If the product terms are independent, then you do not require to decompose this to the lowest level, and in between you can use the expected value of the indicator variable, and your solution QST, which is the unavailability of the systems, will be calculated. So, this is what is our system safety quantification, and all of you please go through the book written by that Kumamoto and Henley, Probabilistic Risk Assessment and Management for Engineers. Thank you very much.